listening to Radio Data, a podcasting radio where we talk about data, cloud, analytics, and AI with different guests, different hosts, and in different segments. Hello, everyone, and welcome to the next edition of the Radio Data podcast. Today, our guest is Arunabh Singh, who works as a director of data science at Willa. Anu, it's my pleasure.
Thank you, Adam. It's a pleasure to join, and we've known each other for a while, so it's fun to do this together and continue to do fun stuff together.
Yes, that's absolutely true. And let's start with the introduction. Could you please tell us more about yourself?
Okay, so I don't want to go through my resume here, but the basic things I want to highlight is that I'm what you would call an analytics and data science generalist. So I have been working within the space for basically 10 years now, and across enterprises of different kinds, from the United Nations statistics team to Yahoo on the bigger side to very, very small startup when I joined Willa. Now it's reasonably big. Truecaller, which was a big scale up that went public last year. So it's been an interesting journey. The other thing is I do not come from what you would call a traditional data science background. So I do not have an advanced degree in mathematics or statistics or physics or even computer science. I did my undergrad in political science and computer science, and then my master's in economics. So I have a much more interdisciplinary and social/behavioral science background, but with a much more quantitative focus. So that's kind of my story. And I've been in Stockholm for the last 6.5 years, working at enterprises of different scale and nature. And I've been with Willa, where I lead their analytics and data science team, basically from the scratch for the better part of 3 years now. It's 2.5. Yeah. Mm-hmm. So that's more or less me so far.
Mm-hmm. That's great. And what Willa is? Could you tell us more? What is your company doing, and what type of data do you collect and process, and what are the business use cases that you implement using this data?
Okay, so that's a long question. Let me answer it one by one. So what is Willa? Willa is, at its core, it's a invoicing and payments app for US-based freelancers. So it's a Swedish company, split between Stockholm and LA primarily, although some people work from some other places as well. We only operate in the US. It's our only market. And essentially, for US-based freelancers, particularly influencers at this point, Willa is sort of their one-stop shop payment solution. So in that sense, they submit the invoice to Willa. We accept the invoice. If the invoice is accepted, then the influencer, or in case the freelancer more broadly, can be eligible to get paid right away. And then it is our responsibility to get money from their client, eventual client. So in a way, it's a classic intermediary between a two-sided marketplace. We are trying to build more products on it, such as debit cards or tax savings and other advanced financial products of different kinds. But fundamentally, that is the core of our business. And we have been live for 2.5, 3 years. So I joined in the spring of 2020 when we were not actually launched. So it was just the 4 co-founders and maybe 1 or 2 other people working. So I don't think I'm the first employee per se, but it would be one of the first for sure. And now we are somewhere in the mid 60s in our headcount. So we've grown quite a bit. Which brings me to the next question you asked about what kind of data do we have typically. So as you can imagine, this is a fairly sophisticated financial technology / finance / credit risk problem that we are trying to solve. That, hey, do we sufficiently minimize our risk on each invoice that we take on so that we can be profitable in the long run, at least on a unit economics level? So there is different ways to do this. Some of it requires more advanced data science than others, but I would argue all of them require a fair understanding and grasp and well-oiled processing around data. Now, the let me break it down into three parts. First one is to have different business reporting and operational metrics. So, defining what a user activity is and like tracking that over time. More classic KPIs for consumer product tech businesses, such as like retention and activation, and like monthly retention and quarterly retention, and uh, uh, in lifetime value calculation and stuff like that. So that's one. The second one is using the data we have on our partners. So of course, that is when they actually interact with the app, either through the front end, which is when they use the app, but also when they make more substantive actions within the app, such as sending a payment request or withdrawing the money, etc. Tracking those over time, and building in the first line of defense a more advanced credit risk operations team. So I have a counterpart who's the head of risk, and that is primarily his domain, but we are the data cleaners and suppliers and data engineers on that side for his work. Where, okay, do we set limits on particular partners based on their default rates in the past, or similar kinds of partners that come in the future? So that is more of what you would call like a heuristic based data science analytics approach. That's the second component of what we do on the operation side. And thirdly and finally, on the data science side, it is to predict the default and fraud rate on each particular invoice or on a particular partner. So there it is a relatively classic classification algorithms within machine learning that we use, except of course we use our own data that we gather on our users through their behavioral usage over time. In some cases, we might rely on some external data sources for like lookups and API, but primarily I would say we use our own internal tooling for that. To sum it all together, there is reporting and business analytics, operational analytics. Then there is the credit risk and credit operation side, and the third is like more advanced data science and credit risk modeling side. To put it all together, I would say that we have a relatively mature data science and analytics setup for a company of our size and infancy. We have a fairly strong, and I'm sure that will come later, like team as well. And I'm actually quite proud of where we have come in a fairly short amount of time when it comes to data science, analytics, and also working closely with other parts of the business to support them make better decisions.
Mm-hmm. So let's assume that I'm a freelancer and I provide creative work for a US-based company, for example, the one from the Fortune 500 list. So if I understand correctly what you said, I can simply issue invoice for my work and then upload it to your Willa app, and then what will happen?
So we can accept or reject the invoice based on, I suppose, our internal algorithms or processes, whether it is we consider you to be a legitimate or a fraudulent partner, of course, but also if it's you might have been with us for a while, but this is your first invoice to this particular client, so that also plays a role. That's a more advanced kind of use case. But typically, we can accept or reject the invoice. If we accept the invoice, then typically you are eligible to for the value of your invoice right away. So in a way, it is instant money in the sense that if you accept your invoice, you can just go and cash out. Mm-hmm. And then you have nothing to do anymore with that particular invoice. It is our problem to get money from the Fortune 500 company that owes you money.
Okay, so you simply take a risk of collecting that money from the end company. And is it actually the most critical use case and the most important machine learning model that you need to develop to make sure that Willa as a company is successful and profitable? Or is there anything else that is more important?
I think there is two kinds of risk that we take within the general category that you mentioned. One is that there is risk on the freelancer side. Like, is this freelancer legitimate? And is this invoice legitimate? So that's something what at least I internally call like a fraud risk. Like, is this a fraudulent case, right? So in that case, we take that fraud risk, and that's on the one side of the market. Let's assume that is in this case the invoice is legitimate and the partner or the user is fully legitimate as well, so we take the risk on. Then comes the second part, which I call the credit risk, basically. So in that case, the invoice is legitimate, but who knows what the financial situation of their eventual client is? Do they want to pay us? Are they is a recession going to happen that will affect their chances of paying? Is that an industry-wide problem, etc.? So yes, there is a risk that we take on the financial side, but typically we use different models and different algorithms and definitely different features, technically speaking, on the fraud modeling side and on the credit risk modeling side.
Yes. It's also very important what you said about the microeconomic environment, because it means that in a given scenario, your machine learning models can be more conservative when deciding if you should pay a given invoice or not. So is it also included as a feature in your ML models?
Absolutely. So that implicitly we include it in that if we feel that our current risk rates are too high, we try to sort of calibrate the model towards being more conservative. So essentially, technically speaking, change the balance of the false positive and false negatives within the accuracy scoring that we do, and tweak the model accordingly. So that's the obvious thing that we do. And there is something else at play here, which is in finances, you might have heard of a term that there is like asymmetric tail risks, right? Which essentially means that there can be a very, very small chance of an incredibly major event happening that is not always very well handled by machine learning. So let's assume that there is a partner that might look very good on paper, but sends us an invoice of $10 billion for Apple, right? Uh, and everything looks great, but their machine learning might actually tell us to accept that invoice. But what I call like the asymmetry of risks is so far on the downside that we probably should not take that on, because even if it's a 0.0001% chance of that event happening, our business gets wiped out. So essentially, we have these backstops in place that uh, kind of augment models with common sense. And I think that's an important part of working in financial services and credit risk as well, is that the cost of low probability, high impact events can be catastrophic. We have seen that with like the fall of very notably like Lehman Brothers, etc. But also with in like financial services in general. I think that's an underappreciated part of the problem, is that uh, data science can only do so much if you don't use common sense.
Yeah. It's very interesting because it introduces more challenges to your business to properly deal with situations that might generate such a asymmetric risk for you. However, you also mentioned that sometimes you need to calibrate your models and iterate on them to make them continuously better. So this suggests that you have some technology stack that helps you to quickly prototype, train, deploy, monitor and especially retrain your machine learning models. So can you describe how you work with ML at Willa and what technologies do you use?
Yeah, absolutely. Our data is our secret sauce, but our technology stack is not. So we are fully hosted on GCP, as far as I know, and have been from more or less since the beginning. I personally, within data science and analytics within my team, am relatively technology agnostic in that I do not have probably because I come from economics, I do not have particular biases for particular technologies. So typically for like upstream plumbing and orchestration, we use dbt and airflow. For data warehousing, we use BigQuery. For quick and dirty analytics, we use the BigQuery console. For the reporting, we use Data Studio. It's not you might say it's not the prettiest tool in the world, but it is included in the Google stack and it works very well with the existing ones. So I just went for the simplest choice in that sense. Some people like Tableau. I think Tableau is very pretty, but this does the job for us. And as startups, we also need to be cognizant of costs. And more on the machine learning side, most of our models are built using Python libraries, and for that we use Vertex AI and Kedro as the sort of hosting mechanisms and more data science modeling infrastructure side. I will of course take the opportunity to say that your crew from GetInData has helped us quite a bit with that part in particular, and it has been quite a fruitful journey. And also, I will also take the chance to reiterate the fact that for a company that's only existed for 2.5 years, our data science and analytics stack is relatively mature and robust and seems to work fairly well. In my past experiences, a lot of things used to often companies would get quite big and then they suddenly would realize the need to build a data science team and have like the infrastructure in place, even for basic reporting. Forget about advanced machine learning. Here, the founding team had the foresight to do it pretty early. So that carries many advantages in terms of not being stuck with legacy technologies on one side, but also having a fresh approach to data science and analytics, in that you have a clean slate that you can build alongside the product rather than have a very mature, very established product and then have the analytics and data science catch up to that. So that was helpful on the process side of things.
So I agree. In my opinion, making an early investment in data and ML platform at a company like Willa is a very smart decision and probably must-have decision. So yeah, but I have one follow-up question. So could you also give us an example how this ML platform looks like and how it's used? So let's assume that you or someone from your team would like to develop new machine learning model, and how he or she will be working with your tech stack, and how long will it take to deploy a new model in production?
I mean, truth be told, machine learning in terms of modeling is roughly 35% of our team's job. A lot of it is more product analytics and also data engineering. Those are big parts of the role as well. Typically, we have put a couple of models in production. Normally, it takes a few weeks, but that's not because of the technological gaps per se. It is more that because we work on a product, firstly, that is quite new and is quite fast changing. We release an app version every week. And also because we are constantly adding features which adds to data sources essentially within the app. A lot of the time goes into feature engineering, which has two components. First is what is traditionally called feature engineering, that you take, whatever your target variable is and do exploratory analysis with the, let's say, new feature that you're trying to add, and then binning and analyzing and making histograms, and that makes sense, adding it to the existing model. But there's an upstream part of that as well, is data pipelines on that new feature needs to be built as well. So that needs to be added to the core data model that using DBT, and that needs to flow into BigQuery, and only then can the data scientists use it. So typically we have taken a relatively cautious approach to that so far, because we want to make sure that our models are robust and good rather than iterate super quickly. That's not the approach some other companies take, and we might change that down the road. But for now, a slightly slower cadence on modeling and a stronger focus on data plumbing and data engineering has served us better, I would say.
And what are the most popular 2 or 3 technologies that your team is using on a daily basis?
So let's say there's a quick and dirty question that comes in from one of the product managers. So a typical one would be to use the BigQuery console/UI to query the data and then visualize it even within Google Sheets. So that's a pretty typical thing to do. Sometimes we use Excel as well. Not to be biased against Microsoft, I quite like Excel personally. The other technology quite commonly we would use is if we want to create a new a variable or a field in an existing fact table or a model, we typically use dbt for that, and that's quite common. I think almost all of us touch that on a, if not daily, then at least a weekly basis. And thirdly and finally, of course, most of our coding is done in Python for the actual models, and the wrapper, in a sense, is Kedro, and that is hosted on Google's Vertex AI. So
Mm-hmm.
we have 5 data scientists on the team, including me, and 2 data engineers. So some data scientists do a bit more on the product analytics side, some do a bit more on the machine learning side. But so that does affect which technologies they use a little bit more often. But I would say everybody uses a little bit of everything, at least in a given week.
Okay, I'm very satisfied with this answer. So let's switch topic a little bit. You mentioned that you manage a team of data scientists and data engineers. And could you explain, based on your experience from Willa and previous companies that you had been working at, such as Truecaller or Yahoo, what are the most important skills and competences that data scientists should have those days? And what should their approach to work be?
So I think my answer will be obviously grounded in my own experience, but also in terms of, I think, let's say, Google's research team will need a very different kind of skill set than an analytics and data science at a company like Willa. So, of course, these answers are not fully generalizable, but I look for 3 things when I'm recruiting, particularly data scientists, although to a lesser extent, this applies to data engineers as well. First of all, it is what I call quantitative aptitude. Now, that does not necessarily mean a degree in math or statistics or even computer science. It means that one is intuitively comfortable with numbers, is intuitively comfortable with breaking an abstract problem down into, if not quantitative, then at least an analytical problem. Some of them will be advanced stats, some of them will simply be count star, some of them will be visualizing things differently, but an ability to break down a problem quantitatively. That's the first thing. And I always test that in interviews using more open-ended questions. The second part is, I think good data science should come with an element of, or good analytics and data science should come with an element of what I call a certain degree of counterintuitiveness, because typically the first snap judgments, the what uh, uh, that come to our mind are sometimes right and sometimes wrong, and that's where data science adds a lot of value in terms of validating them or often correcting them. So the, in like a very fun data science or analytics challenge, there should be that aha moment at the end where you have come through after quite a lot of push and pull and discussions, where the result makes sense on hindsight, but is not immediately intuitive when you look at the problem first up. So in a way, you're creating knowledge along the way, and that curiosity to dig deeper, and also to not be satisfied with the first simple explanation, which often tends to be, if not wrong, then at least incomplete, is a very important part of being a good data scientist. And thirdly and finally, is it's an art to, I view data science and analytics as a function that helps the organization make better decisions. Now, that often is done through data, sometimes just through better storytelling. But eventually, how can you take a non-made decision and make it into a slightly more structured or a better decision through advanced machine learning, or simply drawing a histogram that shows frequency distribution of users across the United States? Either way, uh, it is about helping the other sections of the organization make better decisions. So those are the three things I look for: general quantitative aptitude, an ability to dig deeper, and curiosity to arrive at a slightly counterintuitive final outcome. And thirdly and finally, helping the others make better decision, which often comes with an ability to speak well, to write well, to communicate well, and to present well.
And you gave a disclaimer that your answer might not generalize to other companies, but you worked with data science at a number of places in the past. So how would it be generalized at least to them?
I think to some extent, like to 60, 70%, it will apply everywhere. It might even apply if you work in, I don't know, as a consultant at one of the management consultancies. But the difference being is that bigger organizations typically tend to have more specializations. And there, let's say, if as an example, if Google's YouTube recommendation engine team is looking for a data scientist, then uh, if somebody doesn't have a sufficiently strong background in recommender systems, for example, then they will struggle and feel out of place for quite a long time, even if they have the other criteria. So in a more specialist team, the attributes I mentioned add value, but there needs to be a baseline match of skill level. So, or to put it in a different context, if the entire code base of an organization is written in Java, you can get the best Python programmer, and they will add sort of value in terms of a different problem solving style, but they probably will not be able to contribute a lot if their Java skills are not up to scratch for until the time that they get to the baseline of the organization. So in bigger companies, that specialization tends to happen, and it is natural because specialization makes us more productive as societies and causes economies to grow in the long run. But it does come with the caveat that not every specialist can fit very well in a company that requires more generalists,
Yeah,
and vice versa.
Yes, that's true. And what I'm also very interested to ask you is your outlook for the future. So, what are the most important trends in data science that you see now, or forecast that they will become visible in the next years?
I have a couple of general thoughts on this. I think, uh, unlike most people who claim, most of my predictions turn out to be wrong. So maybe that's kind of the point, is to make wrong ones. The ones I say publicly will end up being wrong, so you should do the opposite. But there's a couple of things I'm quite keen on watching. The first thing is that I think it has been, at least for the foreseeable future, being 5, 10 years, it's hard to foresee things beyond that point. It is difficult to see any kind of mass unemployment or unemployment resulting from machines taking over or artificial intelligence or data science, etc. Not because that is impossible, but I think we as humans have not only found ways to sort of work alongside the machines, which in this case is like some like simple backend code written somewhere, but also realize that there are a lot of use cases that initially thought could be automated away that are actually quite hard to automate. And whether it is like on the customer facing side of things, or what I call like distillation of knowledge kind of things, or making judgment calls. I think that's where in all of those things machines tend to struggle. So one of my predictions would be that yes, we will see more companies adopt AI and analytics sort of as a function more broadly. I do not foresee mass unemployment resulting from this anytime soon. Now, this can change in 10 years, but for the next 10 years, I don't foresee that happening. So that's number one. Now let's see how true that happens. We should talk about it in 2030 or 2032. See how that looks like. The other thing is, unlike many other people, I do not subscribe to the fad of self-serving analytics and AI, or even BI in that sense. It doesn't seem to have been adopted much, and like companies that have thrown money at such products, or have even tried to develop it, have developed cool things, but they don't seem to have gotten much traction. Like most companies still prefer to go to somebody to help them answer questions. Uh, and in a way, I do not think it is a function of the tools. It's just that people like a certain degree of reassurance that comes from a team or a person that a self-serving tool doesn't quite give us. And it's the same thing, for example, with being able to like diagnose an illness. You can probably get that right quite often by going through a checklist or entering symptoms, and the diagnosis will be correct. But in most cases, what will happen is that you will still go to the doctor to validate it, right? So in effect, it ties into what I was saying earlier, is that essentially self-serving is a first layer of curiosity, but after that, there seems to be a fairly large need of some degree of judgment or expert opinion that I do not see going away. So the self-serving BI tools and analytics tools have been empowering to some teams, but mostly to answer very basic questions. And beyond that, they rely on specialists to do that. And the third and final trend is, I foresee that and this I think is a healthy development, is I foresee kind of more SMEs and more uh, companies, even larger ones that are, let's say, in slightly less technologically frontier countries. I mean, in Europe, that could be, now I'm calling it out, like let's say like a place like South Italy or Bulgaria or something, which obviously is not at the same technological frontier as Germany and Sweden. So those kind of companies that are based in these regions will probably start to adopt more artificial intelligence and machine learning tools for a lot of automation. That has already happened in some of the other countries where, or companies where this sort of trickle down effect will happen over the next decade, where second tier firms or non-frontier countries or regions of the world will start to adopt it. And I think that's a healthy development, because that results in a diffusion of knowledge, and also quite likely a leveling up of certain kind of companies and regions as well. Of course, that also ties into something that I had mentioned at the beginning, is that the more these technologies become diffused, the more people will be needed to build them, service them, to get extract value out of them. And again, I do not foresee any major mass unemployment resulting from that. There will be an automation of tasks, but there will not be an automation of jobs. And I think that is my prediction for the next 10 to 20 years.
Yeah, we should definitely talk in a few years to check how many of your predictions will be accurate. And for instance, I can refer to what you said about adoption of AI analytics in different countries. I currently live in Poland, and 3-4 years ago, not so many companies used public cloud in our country. And according to some Eurostat data that I remember, this data summarized the evolution of cloud adoption among enterprises in Europe. And Poland was, in 2016, Poland was a country with one of the lowest cloud adoption, together with countries like Latvia, Greece, Romania, Bulgaria. But recently, the cloud adoption in Poland has more than tripled, over the past few years. And now we are catching up very quickly. One of the reasons for such a fast growth in adoption of the cloud in Poland is the fact that we turned out to be a major cloud location in Europe. So, for example, Google and Microsoft have opened their regions in Poland, and they popularized cloud adoption in our country, and also they removed a lot of legal and regulatory issues, because we have the regions in Poland and we can store our data locally there, what is very helpful for enterprises from regulated industries. However, if I compare this to Sweden, I think that the road to the cloud in Sweden started maybe like 5-6 years earlier than in Poland. And I think that the big milestone in Sweden was a decision announced by Spotify in 2015 that they go to the public cloud. And this very likely popularized the cloud in the Nordics. So many other companies started considering the cloud and moving their data and their data infrastructure from on-premise Hadoop to the public cloud.
And the rumor on the street has it that was a very lucrative deal for GetInData as well.
Yeah, that's true. Yes, yeah. I can also refer to what you said about self-service analytics, because I have also the feeling that it's very comfortable to talk to someone who has a domain knowledge, especially in large companies. So, for example, I recently talked to my colleague from one of the largest Polish bank, and he told me that they have like 10 or 20 definitions of the credit balance that are used by different people in different projects for different purposes in different units. And sometimes it's not that easy to discover what is the proper definition of credit balance that you should use, or what definition is used when you look at this particular dashboard or the numbers. And to make it easier, they, of course, are working on proper data catalog, data lineage, and some data discovery tools, and also data dictionary for their data sets, so that people can be as self-sufficient as possible. But still, there are many situations where you need to talk to someone who understands all this data to explain you all nuances and be sure that you interpret the data in a correct way, especially when you make like important decisions, like related to giving somebody a credit or rejecting it. And also, if you introduce a data mesh at your company, then some particular units are fully responsible for their data, and they know everything about this data, how it was created, who is using this data, where, and somehow they need to also share this information with other units, because they need to export their data as a product to other units. So if they do it properly, then the whole company will be more self-sufficient, but otherwise it might create even more silos.
Yeah. One thing I will add to that is, and again, I think that this is a healthy development, is not a data science machine learning example directly, but more on the industry side. Just as I think consumer tech was the, shall we say, primary boom industry of the last 25 years or so, I think the next 20 years will be green tech. And both in terms of the scale of the problem, the investments that are needed, and that requires what I call not just software engineering, but also real engineering. So, and data and machine learning has an important role to play in that, but arguably not the most important role to play with that. I think that's more on the sort of hardware side, or what is called the deep tech, in a sense, like deep tech in the sense of actual deep tech, not deep learning. And that's where I hope some of our smartest minds and funding dollars and euros and zlotys go there as well. But I foresee that to be the the biggest industry of the next 20, 25 years. And that's kind of the only way we have a realistic chance of staving off at least the worst case climate change scenarios. But also, I think that's a very interesting problem to solve. So that I am hopeful of. And if I were an investor, which I most certainly am not, then that is the sector I would be looking at. Also, like for people starting out in their careers, I guess that would be my advice to them as well, is just as people who joined consumer tech in the mid 90s, early 2000s have done very well professionally in the last 2 decades, join green tech. And you'll probably not regret that decision in 20 years' time.
In Sweden, as far as I know, there are many companies that build innovative solutions to prevent from negative climate changes. So I'm sure that some of them will be successful, or maybe even majority of them. Yeah, okay, so we talk a lot about next 5, 10, or 20 years, but let's now talk about the next year, 2023, especially in the context of Willa. And what do you have in your backlog? Are there like any interesting challenges that you will be facing next year? Can you share any of them?
Yeah, good question. So, funny enough, you have this meeting with me 2 weeks earlier to get an optimal answer, because I have scheduled a team workshop early November to come up with an analytics and data science plan for the next 3 to 6 months. Maybe that's a good starting point for the answer, is that at a company of our stage, and also the macroeconomic environment being what it is these days, I personally view planning horizon as 3 to 6 months, basically, at this point. And that gives enough time to take on big things rather than just working day to day. But it also prevents us from getting stuck into like 2-year kind of projects that are hard to keep track of. So that's my guiding star on the project management style, at least at this point. The interesting things are, amazingly enough, not so much new stuff, but doing more of the same and doing it better. So I talked about the credit risk problem on an invoice level, trying to predict if we'll be paid or not. So taking that further, by now that we have more users and we have more invoices, we have more data. So not only retraining the model, but also that opens us to ideally different kinds of algorithms that work better with more data, but also we have more features to train. So doing deeper on that side. Another thing is that now that we have been live for more than 2 years, it'll be 3 this spring, that gives a fairly substantial amount of time on user behavioral data as well. So that's more on the advanced product analytics side and less on the data science side, but having longer term predictive analytics on the user side. So, hey, what kind of users are likely to stay with us after 2 years? Like, what is that? Rather than somebody who stays 3 months, they might be very different than somebody who stays 2 years. So we can do longer time series product analytics as well. Who churns, who stays, who reactivates. So that kind of stuff. And thirdly and finally, more on the data engineering side as well. Our data platform, as I said, is fairly robust and fairly strong. I think it will hold if we have 10x the data. I'm not sure if it will hold up if we have 100x the data. And we should plan for that kind of a contingency scenario as well, that, hey, if we have 100x the data, then, as you know, overhauling a data warehouse is 3-4 month process, even at a company that is quite young like ours. So that will be probably happening end of this quarter, early next quarter, is to do version 3 of our data warehouse. The first version was built by me, who was an economist, so that was probably as bad as you can imagine. The second one was built by very good data engineers. I think one of them was GetInData one, and one of them was an internal hire, and they worked together on that, and that was very good. But now it's time to look ahead and make a more robust data warehouse. So I mean, now it's a bit more technical answer, but like coming up with more specialized fact tables for particular business units that they are more interested in, and having more checks on the data cleaning side, so that there is less or almost no duplication rather, and that kind of challenges. So advanced data engineering challenges to be overcome. That kind of covers three areas: fine-tuning the data science model, doing longer-term product analytics, and revamping the data warehouse. That takes care of at least 6 months, I would say.
And do you also consider entering new markets? This can also increase the amount of data points that you can store and analyze, and it can also introduce many new challenges to your machine learning models, because in different countries you can have different freelancers, different behaviors, different companies, also different regulations, and also like different level of risks associated to them.
Yeah. So, I mean, obviously, entering new markets is not the decision of the data science team. But as far as I'm aware, there isn't any plan to do that. I mean, as you can imagine, the US is a pretty big market to begin with, but also it's a relatively big, what I call frontier market on the influencer and freelancer side in particular. Like if we were, I don't know, working with the car industry, then it might make more sense to enter the German market, but that's not really the case here. So, I think focus is quite important for us, and getting to grow at a certain scale within a certain country is important first. It is more likely to happen that we might enter different kinds of freelance segments. So right now we primarily work with influencers, but that is simply just how things happen. We might also decide to service all plumbers across Wyoming, for example. Like that is a fairly large freelance category as well. And I think I'm not sure if what kind of expansion, whether it's like different markets will happen first or different kinds of freelancers will happen first. But to your point, you're right. Both will introduce a substantial amount of heterogeneity in the existing analytics space, in the business problem space, and obviously in the machine learning model space, and might need completely different models and features and validation criteria for different kinds of segments as well.
Exactly. So the solutions that you build must be not only scalable, but also flexible enough to adapt new data sources, new users, and new use cases.
Yeah. While it would be really awesome, but I do not see, at least myself, maybe my team is more capable than me, of coming up with the next one model to rule it all. And so I think we might have to, take it case by case as it happens.
Okay, and this was actually my last question. So, Anu, I would like to thank you for this fantastic conversation and sharing your knowledge with us. Definitely, we should meet in a few years to check your predictions, how likely they are to happen, and to what extent.
So I made 4 of them. Let's see if I've gotten better. I think as a more senior data scientist, my predictions should be getting better with time, but only time will say that, right? We are waiting for the validation set to emerge at this point.
Yes, definitely. So what makes new predictions difficult is the fact that we live in a world that changes so fast and so much. So, for instance, 2 years ago we had the pandemic, and now we have the war in Ukraine. We also have very high inflation and very high interest rates. Maybe they are not historically high because we had higher interest rates a few decades ago, but definitely we have, for instance, record amount of debt, which has many serious implications to the world that we live. So it's great that your company, Willa, is building the app that helps to collect that debt sooner and faster and reduces it. So I wish you best luck, and thank you again for this conversation. If you are interested in new episodes of Radio Data, please follow us on Acast, Spotify, and other podcasting platforms. Also visit GetInData.com to find more information about other ways that we gather and share the knowledge.